Hi everybody, welcome to video 4. Good news, video 4 and video 5 and potentially video 6. All practice of this mole bridge. Using it, getting good at it, getting comfortable with it. So video 4 is all going to be practice with these mole conversions. Now, you're going to have a lot of practice and you're going to have a lot of practice sheets assigned to you. We are going to be doing the first, see how many there's, so a total of 6 examples. We're going to be doing the first 3 examples off of mole conversions. Homework number 1. So 6 examples, we're going to do 3 of them together. If you think you've got it, pause the video, try and do it, and then play it back later on your own. But working on mole conversions, remember we're working with this 3-step kind of mole bridge where we can go from grams to moles and from moles to particles for any substance. Example 1, you are asked how many moles are in 68.8 grams of water. Okay, so I am starting at grams. I am going to moles. So this is a one-stepper. Start with what you know. I know I have 68.8 grams of water. I know I can go from grams to moles. I know grams needs to cancel, so grams of water is going to go to the bottom. Moles of water is going to go to the top. And using my weights, I know that 1 mole of water contains blank grams of water. Now, water is not something you can find on the periodic table. So molar mass of H2O would be 2 hydrogens. So 2 times 1.007. For our purposes, that is 1. Plus 1 oxygen. So 2 times 1.007 plus the weight of oxygen, which is 15.99. The weight of water, and this is going to be a weight of water that we use a lot, just round it. The molar mass of water is 18 grams per mole. So 1 mole of water weighs 18 grams. Get your calculator out. What do we start with? 68.8. 18 is on the bottom, so divide by the molar mass. I end up with 3.82 moles of H2O, which was my end goal. Again, make sure you're not just pulling in a molar mass for hydrogen. Calculate the molar mass of the compound. Track your labels so they cancel diagonally. And then 1 mole of a substance, make sure you get that 1 with the mole and then the mass with the grams. So that's number 1. These problems, once you're good at them, they will go fast. They just take a lot of practice at the beginning, but once you've got it, you'll really get it. If you don't have it yet, don't worry about it. Just keep on trying. Number 2, we're going to be looking at a different compound. We are going to be looking at how many grams are in 4.75 moles of CO2. How many grams in 4.75 moles of CO2? Now, normally, when I see it's a compound, the first thing that I'll figure out is the molar mass of that compound. CO2, well, I know the mass of carbon is 14. I have 2 oxygens, so I have 15.99, so 16 plus 16 plus 1 carbon is 12. Molar mass of CO2 is 44 grams per mole. Start your problem off. What do I know? Well, I only have one number. I know I have 4.75 moles of CO2. From moles, I can go to grams. Moles need to cancel out, so it goes to the bottom. Plug in my molar mass conversion factor, which I already figured out. There are 44 grams in every 1 mole. And then use your calculator. 4.75, the 44 is on the top, so you multiply, and you end up with a total of 209 grams of CO2. Always a good idea to double check and make sure you answered your question. We asked about grams. We got to grams. We're good. Each of these were just 2-steppers because we were going from moles to grams and then from grams to moles. Question 3, calculate the number of molecules. Remembering, molecules, particles, or grams all kind of stand in, but calculate the number of molecules in 3.7 moles of sodium chloride or NaCl. Again, we're working with a compound, so first step, got to determine the molar mass of that compound. NaCl, this one's pretty easy because it's just one of each atom. So one sodium atom has a weight of 22.9 or 23. One chlorine atom has a weight of 35.4, or I think I rounded these to whole numbers, 35, yeah. So 23 plus 35. Sodium has a molar mass of 58 grams per mole. And actually, I should have double checked my mole step first. Now that I can see my conversion, calculate the number of molecules. We're comparing molecules and moles. So I actually never need the grams. So that was actually unnecessary. I didn't need the molar mass of NaCl, but if you're just working through the process, never going to be a problem to accidentally calculate it. Start with what you know. I know I have 3.7 moles. Moles needs to cancel. And I'm going to molecules. So moles to molecules. Moles to molecules, moles to particles, that's always going to be Avogadro's number. Maybe I'll write that up here. The 1 goes with the mole. The number goes with the particles, or in this case, they're being specific and saying the particle is a molecule. And then all that's left is to calculate it. 3.7 times 6.02 times 10 to the 23rd. And I end up with 2.26, rounding it to 2 sig figs, so 2.3 molecules of NaCl. 2.23 molecules of sodium chloride or NaCl. Okay, so I want you to go ahead, try the other three. Number 4 is moles to molecules, so that's going to be a lot of what we just saw here. Number 5 is atoms to grams, so that's going to be the whole way. And then number 6 is grams to molecules, so again, that's going to be that whole way. Using Avogadro's number over here and using the molar mass as your conversion factor over here. But go ahead and try those last 3 on your own.